Hey everyone, it's Mr. Canfield. Today we're going to be looking at compound inequalities. So sometimes we're going to have situations where there's two different parts of the number line shaded. So how do we use inequalities to represent this set of numbers? Remember, how do we use the little mouth guys? That's the technical term, right? So the little mouth guys. No. Okay, so let's talk about this. So if we just had this guy, we could say, well, we know there's going to be x and there's going to be 2, and our shaded region, is our shaded region greater or less than our answer? Or sorry, than our number 2. So the shaded region is to the right, and to the right is greater. So that means that x is going to be greater. And then we have to ask ourselves the question, can it equal 2? Well, let's see, is it filled in on 2? No, so it can't be 2. And if it was just this guy, well, then we could say, I'm gonna have to write with my left hand right now. Whew. Oh, it's not that terrible. So this time, here's our number, -3. And are we going to the right, or are we going to the left? Are we going to the greater or going to the less? Well, we're going to the less. So that means it doesn't want to eat x, it wants to eat the 3. And then we can say, well, are we allowed to be 3? And since it's filled in, yes, we are. So this is going to have the line underneath. All right, so how in the heck am I supposed to write this as some inequality that it's this and this at the same time? Well, you can't be this and this at the same time, right? You're either more than 2 or you're less than 3 or equal to it. And so we just throw this word in there, or. So the word or in math, it can mean one, the other, or both. So sometimes we'll use the word or and we're actually allowed to be both. So let's look at our next example down here. We've got 10, we've got 15. Well, so if we look at the 10, we can say, hey, x and 10, well, 10's the farther right out of everything, and it's got a line underneath, so we'll put the line, it's filled in, so we'll put the line underneath. And likewise, here's 15, so we can say, well, there's x and there's 15. Well, this time our shading goes greater than our number 15, so let's say x is greater than 15, and it's filled in, so the line goes underneath. If you did not remember that a filled in circle means the filled in line underneath, you might want to write something down like filled in dot means line underneath. You know, like I would write something like that if I forgot that. And then you could even write something like, remember arrow trick. You know, we have that arrow trick where x is on the left, you know, this is a little arrow that points in the direction that it's shading. So remember that when we take notes, we can fill in all sorts of extra things that are helpful to us. And since you're watching a video, you're going to be able to pause this anytime I say something that catches you off guard. You could always pause the video, think about it, or pause the video and rewind, or write something down. Lots of options here. Okay, let's see what's next. Wait, these are weird. It's like last time they were colored like going away from each other. Now they're colored going in towards each other. So this is one way to write this. One way to write this is, well, we can say there's x, -4, and let's see, it looks like we're shading greater than -4, we're going to the right, so and we're allowed to be it because it's filled in. At the same time, we're looking at 1. Oops. Let me just tell you how I got that. We're looking at 1. It's an open circle, so I know there's no line underneath, and the shading is to the left of it. Now here's the thing. We are in between these two. We are both greater than -4 and less than 1 at the same time. And so in math, we use the word and for that situation. Here's the thing. There's a cleaner way to write this inequality, or this compound inequality. Let me explain the word compound. I've been doing them, but I didn't talk about where they come from. The word compound just means like there's more than one happening at the same time. Apparently a compound word takes 2 words and pushes them together. So I like to say, see how x is squeezed in the middle here? Well, we actually squeeze x in the middle here, and we write the numbers. And then we just throw 2 inequality signs. Don't pay attention to the way that we wrote them here. That doesn't make sense. Instead, think about, because the x is on the left in both of them, here x is on the right of one of them and left the other. So our little trick doesn't work here. But if the x wasn't there, which way would the mouth go? Which one would the mouth want to eat? The mouth would want to eat the 1. So we say, hey, mouth, eat the 1. And you know what? There's another mouth over here that's also trying to eat the 1. Doesn't care that x is in the way. X is supposed to be more than 4 anyway. So now the other thing we got to figure out is, do either of these get a line underneath? That just takes us to here. Do either of those give us a line? That one does. So we'll put the line under that one. And now we've got our compound inequality. This is the better way to write this. Well, it takes less time. So I'm just going to write this the new way using our compound inequality. Our 2 numbers are -100 and 50, or -50. So which one of those is greater? Here's the thing. If you always go from left to right, the mouths always go the same way. Do either of these get a line? Let's see, no, no. All right, so that'd be my inequality. Okay. I think we have a total of 8 examples today, so we are already halfway through. But now, we run into this. Solve the inequality, the compound inequality, and graph the solution. Okay. So this is where having multiple colors can be really helpful. So I will use pink and green. Pink and green. So if I'm trying to solve, now it's really, really simple. You just took a quiz on this recently. You just solve that like you would normally solve it. So we just do our normal solving moves, right? Remember, adding and subtracting comes first, so I'll add the 7 to both sides. Bam, bam. Right, we're left with a 5x over here. That symbol stays the same. 13 plus 7 is 20. Then we'll divide both sides by 5. Now that was not a negative, so it just chills the way it normally would chill. 20 divided by 5 is 4. So we'll look at graphing in just a minute. Actually, we're going to look at graphing right now, all right? No, because I don't know what the answer is over here. I want to see what the answer is before we do anything else. Okay, I said I was going to do green for the other one. Sorry, grin. Has some grin. -4 plus 3, or -4x plus 3 is greater than 11. Ooh. Did I get you? Did you yawn too? Sorry if you did. I know they're contagious. So I see the plus 3, I do the opposite, subtract 3, so I get -4x. That symbol stays the same. 11 minus 3 is 8. And now we divide both sides by a -4, by -4. We divided by a negative. Remember, when we divide by a negative, the symbol in the middle flips around. Dun, 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 dun. Right there, okay. So negative 4 divided by 4 cancels. The symbol flipped. 8 divided by negative 4 is negative 2. Okay, so we're going to graph both of these solutions on the same number line, and their overlap is going to be our final solution. Oh, I'm lying. I'm wrong. Or, we'll talk about it. We'll talk about it. Let's graph it. Okay. So we got 4 and negative 2. Those are going to be our two numbers. So let's not confuse anybody and just use a neutral color. Okay, so we know one of our solutions starts at 4. And then is that an open circle or a closed circle? Well, there's no line underneath, right? So that tells us open circle. And then it says less than. It's also pointing to the left. So we know that we're going this way. And I'm going to go all the way to the end because I want to kind of give myself some chances to figure out what's going on here. Okay, then our other solution, and this problem's really looking like a watermelon, isn't it? We got the pink, we got the green, and now we got the black for the seeds. So let's see, negative 2. Well, negative 2 is over here. No line, so it's open. And then it's less than, so it's over this way again. Oh, okay. So that means that our solution, remember, we said, so that says our solution. Let's see, I don't know if my battery alarm just came on, so I don't know if I lost you for a second. We know or means one, the other, or both. So we know we can say, well, I have one of them that starts just up to 4, but not 4. So open circle on 4, and goes forever. The other one starts at negative 2, goes forever. Can I include negative 2 in my final solution? Well, the green one is not there, but the pink one is. So since one of them is there, that means that we're good, because it can be one, the other, or both. So our final solution is actually going to look like this. So it's going to go from 4 left, including everything, even that open circle there, since it got filled in by the other one. Instead of saying or, if this had said and, the only amount that would count is their overlap, which would start here and go to the end. So that's, we'll get into that a little bit later, but that's something to keep in mind. I don't know about you, I was kind of expecting those to go opposite directions like they normally do. Let's see what happens with this one. Let's see. Oh, I did the left one in pink last time. I'll do the left one in pink again. Negative x plus 4 less than or equal to negative 3. Wait, there's no number there. It's a 1. So negative 1x plus 4 less than or equal to negative 3. Remember, when there's no number written in front of a letter, there's secretly a 1 hiding there. So I can subtract 4 from both sides, right? Over on the left-hand side, we have negative 1x. On the right-hand side, negative 3 minus 4 is negative 7. Maeve doesn't like negative numbers, clearly. And then we'll divide both sides by our negative 1. Ooh, we divided by a negative. Remember, that's our little trigger, right? Flip of the sign. So we have x over here. Negative 7 divided by negative 1 is positive 7. I think I need to come back to the video. Be right back. All right, so we got the 1 done. Now let's get the other one done. So 2x minus 5 less than or equal to 7. So normal solving moves, we'll add the 5 first, add the 5 to the other side. We're left with our 2x. Symbol's just chilling. 7 plus 5, 12. Then we'll divide both sides by 2. Let's see if our trigger triggers. We're dividing by 2. Is it a negative? No, it's not. So we don't flip it, keep it the same. We got x over here. 12 divided by 2 is 6. Now, ladies and gentlemen, I have had a bunch of people who need help on solving stuff like this, and only a few of them have gotten the help they needed. But when you come in and you get the help that you need, you'd be surprised how easy these can be. But it might take you actually admitting that you need help, emailing me, or spending some time with me. I'm happy going through problems with you. When we do it one-on-one and I help you out one-on-one, you'd be surprised how much easier it can be. All right, so pink is 7. Circle, and it doesn't have the line, so it does have the line, so it's filled in. Blah, 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 blah. And then it says x is greater than that, moving off to the right. So we go off to the right. Boom, there that is. Then the other one says x is less than or equal to 6. So we go to 6. This one has the line under it, so we know it's filled in. And it says less than, so it's off to the left. So it says or. That means this is our answer. Or means it can be one, the other, or both. So these are never overlapping, but there's those there, there's those there. That's cool. We're good. If our homework ever asks for interval notation, don't worry about that. We deal with that in later courses. You don't need that in this course. So feel free to get that part of the homework wrong. Yeah, if this was an honors class, we'd probably talk about it, but I don't want to stress you out with that. So if you see anything about it says interval notation, don't worry about it. I assigned that by mistake. All right, 2 more examples. What? I'm confused. I'm used to seeing like this, or seeing like this, but what the heck are we supposed to do here? So here's what we do. Focus in the middle. Pretend that it's like this. How would you solve this? 7x plus 9 less than 16. You'd subtract the 9 from both sides, right? Well, here's the thing. Since there's these 3 sides in this special compound inequality, all you gotta do is subtract it from whatever you do to the middle, do to both the other sides. So we'll subtract the 9 here. We'll also subtract the 9 here. That's all. So let's see. 16 minus 9 is, I almost said 25. That'd be 16 plus 9. 16 minus 9 is 7. And then we have our 7x left in the middle. And then negative 12 minus 9 is negative 21. Then we'll divide. Then we'll divide. Then we'll divide. There, now they're uniform. Check it out. 7 divided by 7 is 1. Over here we got x. Negative 21 divided by 7 is negative 3. Oh, I didn't check my trigger. I didn't divide by negative 7. It wasn't a negative, so I don't flip anything around. And here, if we cover this up, is that true? Are the mouths eating the right one? Because that's how we know. That's how we know it's doing the right thing. Cool. So, go to our number line. Wait a minute. We did these before, right? We had negative 3, 1. All you gotta do, anytime I go from a negative to a positive, I like to throw a 0 in approximately where it would be. I got negative 3, I got 1. Do either of those get filled in? Let's see. Oop, that one's got a line, it gets filled in. And it's everything between. So I like that when x is squeezed in the middle, you shade in the middle, straightforward. Let's do one more like that. This is our last example for today. We'll do some word problems together. So again, we just kind of pretend it's like that. You'd start out, you'd add the 8 to both sides, but instead of just adding it to both sides, you add it to all 3 sides. So 2 plus 8 gets us 10. Negative 4 plus 8 gets us 4. Then we get 2x here. If this had been a negative and we divide by it, we'll just flip the signs around. Everything still works. You still shade in the middle. Nothing out of the ordinary. We divide by 2, divide by 2, divide by 2. We get x in the middle. Over here, 10 divided by 2 is 5. 4 divided by 2 is 2. So here's 2. Here's 5. Sure, why not? Here's 0. 1, 2, 3, 4. That's a little bit off, whatever. These are all just estimating anyway. Let's see. I don't fill that one in, and I don't fill that one in. I just shade in the middle. You're right, Maeve. That is exciting. All right. Well, I hope this video was helpful. I will be around, though, if you have any questions. You know where to find me. Bye.